Good morning, students. For this lecturing video session, I am going to solve a problem from the chapter Projections of Plane Surfaces. Let me just read out the question and make you understand what has been asked and what needs to be done. That means the projection needs to be done. A pentagonal plate of side 30 mm is resting on HP and VP with one of the corners. With its surface inclined at 45 degree to HP, the opposite side of the resting corner is parallel to VP and far away from it draw its projections. So here the object is a pentagon, right? Pentagonal plate. So given data. Here the object is a pentagon of side 30 mm. So S is equal to 30 mm. S is nothing but side of 30 mm. Is resting on HP and VP with one of the corners. So how it is resting? Where it is resting? It is resting on HP. How it is resting? Look at here, with one of the corners. So, resting is on corner. Resting on HP and VP with one of the corners. Right. And the surface inclined at 45 degree to HP. So, here the corner is on both HP and VP. Right. Corner on both HP and VP. So, mention it. And the surface incline is 45 degree to HP. So, surface is inclined to HP at an angle of 45 degree. The opposite side of the resting corner is parallel to VP. So, the special condition, usually the edge inclination will be there, isn't it? Here the special condition, what it says, the resting corner is parallel to VP and far away from it. Opposite side of the resting corner is parallel to VP. Fine. So, first let me draw the reference line, which is nothing but the XY or the ground line, VP and HP. Here the object is a pentagon. How many sides it has? It has 5 sides. 1, 2, 3, 4 and 5 sides. Right. So, how to find the internal angles? There is a formula. 2n minus 4 into 90. Suppose you forgot it. You forgot the angle, internal angles. So, pentagon has 5 sides, right? So, 2 into 5 minus 4 into 90, which is equal to 10 minus 6 into 90, which is equal to 540 degree. All the 5 sides. So, for per side, that means each side could be 540 divided by 5, which could be 108. This is applicable for square, hexagon and all the polygons it is useful. For an example, if it is of hexagon or square, for an example square, let me just take square. How many sides square has? 4 sides, right? 2 into 4 minus 4 into 90. 8 minus 4, 4 into 90, which is equal to 360. How many sides the square has? 4 sides. So, 360 divided by 4, which is equal to 90. So, remember this formula so that it would be easy to remember the angle of pentagon, right? Fine. So this is the pentagonal object, right? Here how it is resting? It is resting on HP. Okay, somehow it is resting with one of the corner on HP and VP. So corner should come on the right hand side. Look at the surface inclination. That really matters, because where the surface is inclined, there you will see the true shape, that is parallel to that particular plane. Look at here, surface is inclined 45 degree to HP. So it is resting with one of the corner. So it is in this manner. Look at here, it is resting on corner at an angle of 45 degree with HP, because this is horizontal plane and board has a vertical plane. This is how it is resting. In order to get the true shape, this HP 45 degree becomes 0. So it is now resting. Now this plane surface is parallel to HP. When you look at from the top, you could see the true shape of this object. From where to start? Where you get the true shape. The true shape is obtained on HP, therefore the first diagram should come on HP, the true shape. The next stage, surface is inclined at 45 degree, right? Surface is inclined. Stage 2 is over. Now the third stage belongs to edge inclination or special condition. Is there any edge inclination here? No, it is not given. In place of that, it is specified some condition. What the condition says? The opposite side of the resting corner is parallel to VP and far away from it. This is the resting corner, right? Opposite side is, this is the side. Now, this side, the opposite side is parallel to VP. Parallel in the sense, you can keep this also. Now, this side is also parallel to VP, right? But what the condition says? Far away from it. Far away from it, if its surface is inclined in this manner, right, it is kept in this manner. Now this side is far away from it, and this corner is on both HP and VP. Just observe it how I am going to draw the projections here. So there would be 3 stages, isn't it? There would be 3 stages. The stage 1 is for the symbol position or symbol resting. So here, as far as stage 1 is concerned, you will have to draw the true shape, either it is on VP or HP. If the surface is inclined to HP, the first diagram should be drawn on HP. If the surface is inclined to VP, then the first diagram should be drawn on VP, because we make the surface is parallel to any one of the plane, right? Right. Second stage, stage 2, belongs to the surface inclination. Surface inclination. And stage 3 belongs to edge inclination or special conditions. Edge inclination or special conditions. Right. As I told you, I have to start the diagram on HP because the surface is inclined to 45 degree to HP. When it is resting on one of the corner, if I make the angle with HP become 0, it would be like this only. The surface is parallel to VP, so the original shape, that is a true shape, will be obtained on HP. So to start with, the corner should come on the right hand side. So in that case, draw a line perpendicular to XY. What is the size? 30 mm. Take 30 mm in your scale and draw a line. Now, you have to draw the pentagon shapes. It has 5 sides. Keep your protractor in this manner, both the sides. Now take 108 degree. This could be 90 degree. From here it is 90, 100 and 108. Something like this. Extend this line. Similarly here, this could be 90 and more than that. So this could be 108. So extend this line. Now take 30 mm, that is the side of the pentagon, right? Take 30 mm in your compass, keep it at this point, cut an arc. Now without changing the radius, that is 30 mm, keeping at this top corner and cut an arc. Now without changing the radius of 30 mm, keep it at here and cut an arc. Keep it at the intersection point here and cut an arc. Now connect it. Now connect it. By doing so, I got the shape of pentagon. Shape of the pentagon. Right? So, this is what the pentagon, right? So, the corner has been kept on the right hand side. You always remember how it is resting. It's resting with one of the corner. So, the corner should be on the right hand side. Now, let me just give the naming for it. Starts from the left extreme, A, B, C, D and E. This is the top view, right? Now, front view, what you have to do? You have to project this line vertically upwards. So, B and D should lie on the same line. Extend this. So, this is the boundary, right? If the object is kept in this manner, when you look at from the front, you could see a straight line. A straight line. Got it? Now, look at from the bottom. What are the corners would be visible when you look at from here? This would be A, B, C, D, E. When you look at from the front, A, B, C are visible. D and E are invisible. Right? So, A would be visible, A dash. B would be visible, B dash. And C would be visible, therefore C dash. What about D and E? E is right behind A, therefore that is invisible, which should be captured within the brackets. And D is right behind B, therefore D should be captured within the bracket. Right. Now simple resting or simple position is over. Let's move to the next stage, that is surface inclination. Here the surface is inclined to HP 45 degree. Right. Surface is inclined to HP, this is how. So in the front view you could see the inclined line, right, of 45 degree. Choose a point. Keep your protractor in this manner. And draw a 45 degree line. Draw a 45 degree line. This could be 45 degree. Right. Now how it is resting? With one of the corner C, with point C is resting, right? This is how it is resting. So this point is on the XY line, is on the HP. So C. So C1 dash. Now measure the distance between A and C in your compass. Keeping at C, cut an arc. This extreme point would be A1 dash. Remove the unwanted lines. Now measure the distance from C to B in your compass. Keeping at C, cut an arc. This could be B1 dash and D1 dash. What about the extreme point? E is also on the same line of A. So now extend this line. Sorry, there is make a dark line. This is the object line, right? Now what about the top view in stage 2, the surface inclination? It is inclined in this manner, right? When you look at from the top, you could see a skew shape of this pentagon, right? For which it's a simple method. We'll have to project the projectors from the top. That means the front view. From the front view, draw a projectors which should be perpendicular to the XY. Now from the top view, we'll have to draw the horizontal projectors. Horizontal projectors. Right. So by doing so, I got a box over here. Now I'll have to do the graphing or mapping work here. For which, look at the intersection points, that is horizontal as well as vertical projectors. A is here, so A and A are merging here or intersecting here. This becomes A1. B is here, B is here. This becomes B1. Similarly, C and C are intersecting here. This becomes C1. D is here. D and D are intersecting here. Therefore, this becomes D1. E and E are intersecting here and this becomes E1. Now connect all the sides by using scale A to B, B to C, C to D, D to E and E to A. Now you could see a skewed shape of this object, that is pentagon, right? What is next? The third stage belongs to edge inclination or special condition. Is there any edge inclination given? Is there any edge inclination given? That is, edge is inclined some degree with VP, because here the surface is already inclined to HP. Therefore, in this stage, that is third stage, it should be inclined to VP, right? But in this case, as far as this question is concerned, there is no edge inclination. Besides that, it is given that opposite side of the resting corner is parallel to VP. How it is resting? It is resting with one of the corner. What is the opposite side of this corner? AE. That should be kept parallel. This is how. This side should be kept parallel to VP and far away from it. So if I tilt in this manner, because this corner here, look at here the corner, one of the corner is resting on HP as well as VP. It is resting both HP and VP. So therefore, this position should be kept in this manner. Therefore, the corner is resting on HP as well as VP. This opposite of the resting corner is parallel to VP and far away from it. This is the condition, right? So usually what we used to do in order to reproduce or transfer this information to the next stage, we used to construct a box. By tilting the box, this object would be tilted over there, right? For which, let me just consider this as a box. Let me just give the naming for the box, the boundaries 1, 2, 3, 4 in Roman letters. Now, this corner should be kept on the XY line, right? This is how. This corner should be kept on. So therefore, Roman letter 2 and 3 should be on the XY line. So let me just mark this as 2. Now measure the distance between 2 and 3 in the compass. Keeping at 2, cut an arc, this becomes 3. Look at here. The box, the corner of the box is perpendicular to, this corner is perpendicular, right? Now draw a line which is perpendicular to the points, perpendicular line. The opposite of 3 is 4, right? So measure the distance between 3 and 4 in our compass. Keeping at 3, cut an arc. This becomes 4. Opposite of 2 is 1. So measure this distance 2 and 1 in the compass. And keeping at 2, cut an arc. This becomes 0.1. Now join it. So now I have got this box. The same box has been tilted at, look at here, this is perpendicular. Now look at here, this E is on the XY line, right? So now look at here, between 1 and 2, one point is there, that is B. Measure it from 1 to B, keeping at 1, cut an arc towards B. So this is B2. Between 2 and 3, corner C is there. So measure it from 2 to C and keeping at 2, cut an arc. This is C2. Now between 3 and 4, D is there. Measuring it from 3 and keeping at 3, cut an arc. This becomes D2. Between 4 and 1, I have 2, A and E, right? So measure it from 1 to A, keeping at 1, cut an arc. This becomes A2. Now keeping at 4, stretch your compass to E1. Measure the distance. Keeping at 4, cut an arc. This becomes E2. Now connect all the edges or sides. That is A to B is one edge. B to C is next. C to D is the next side or edge, right? Next, D to E is the next edge and A to E. Now this particular image, that is the top view, has been tilted, keeping the corner is on VP and this side is parallel to VP. This is what the question says. What about the final front view? It's very simple by doing the graphing work, for which all the projectors needs to be extended vertically upwards. So extend this line, projectors, vertical projectors, all the corners. Now from the front view, draw horizontal projectors. Now I got a box. So the image is going to come within the box only. That the final front view should come within the box. Now what I have to do? I have to do the mapping, that is nothing but the intersection points. That is horizontal projectors as well as the vertical projectors meet one point. Right. So now A is here, This could be my A2 dash. E is here, This is my E2 dash. B is here, look at B and B are getting intersected here, so B2 dash. D and D are getting intersecting here, so D2 dash. What about C? C and C are getting intersected on the same point, C2 dash. So now allow to draw the sides, right? So A to B is one side, B to C is next side, C to D is next side, D to E is next side, and A to E. So now with this particular object, look at here, this corner is on both HP and VP. This corner, what it says, resting on HP and VP with one of the corners. So this corner, look at here, what did I keep as condition? C on the right hand side. Look at here, C is on HP. Look at here, C, that corner is on HP and VP. Now it satisfies the condition which is mentioned in the given problem. What is next? After completing the projections, now I have to do the dimensioning work. What is the side of the pentagon? This is 30 mm. So draw a perpendicular line to the side and parallel to the side, which is perpendicular is nothing but the extension line and parallel to the side is nothing but the dimension line of 30 mm. So over the dimension line mention 30. Then what about the inclination? I have mentioned the surface inclination is 45. As such, here there is no edge inclination. In place of that, special condition has been given. I have completed this. Next, the notes. So you have to open up the guideline of 5 mm height. All dimensions are in mm. Next, the scale which is being used. So as such, I have not used any special scaling. So whatever the dimension given, I have captured here. Therefore, it is a true scale 1:1. Hope you have all understood how to construct the projections of the pentagonal plate. Thank you.